Hello everyone and welcome to the lecture on kubectl stateful set commands. So first we'll set the alias k equal to kubectl, and this will save us some typing. Next, to get all the stateful sets, we'll run this command k get sts, and this will list stateful sets in the current default namespace, and the output may look something like this. You will have a name of the stateful set, whether it's ready or not, and the age in days. Next, to get stateful sets in a specific namespace, we will run this command k get sts followed by -n and the namespace name. So this will list stateful sets in a specific namespace, and the output will look something like this. So it will not tell which namespace, so it will automatically list all the stateful sets which is in the namespace which you have specified. Next, to describe stateful set, k get describe sts, then followed by stateful set name and the namespace name. So this will show detailed information about a stateful set, and this is the most critical debugging command. And the output may look something like this. You will have name, namespace, creation timestamp, any selectors, labels, annotation, replicas, update strategy, pod status, pod template, volumes, volume claims, and all the events. Next, to create or update stateful set, you can run k apply -f and the YAML file name. So this is the standard declarative way to create or update a stateful set from a manifest file. So you will get message something like this back saying the stateful set is created, or for updated it will be configured. And if you have multiple objects in a YAML file, this will be service created and all the stateful set created. Any persistent volume claim or persistent volume, whatever is there in the YAML, it will show us it will show the message that it is created. Next, to delete stateful set, so k delete sts followed by the stateful set name. So this deletes a stateful set, and note, by default this does not delete the associated persistent volume claims, PVCs, and this preserves the state. So you issue the command k delete and the name and the production, and you will get the message saying that it's deleted. So edit stateful set, k edit sts and stateful set name and the namespace name. So this opens the stateful sets manifest in the default editor for live changes, for example changing the image or replica count. So this is how it will open up. So you will have the whole YAML in the default editor, so most likely it will be in VI, and you can make edits and it will be immediately applied. Next, to get the YAML file, k get sts followed by the stateful set name, namespace name, and -o for output and YAML. So this retrieves the full YAML manifest of a running stateful set, and you will get the whole thing onto your console. So you can redirect it to a file, or you can just read the content. So something like this, you will get back the whole thing. And to scale a stateful set, you will run k scale sts stateful set name, replicas, and the namespace name. So this is same as deployment, but you will say sts. So this scales a stateful set up or down. The scaling is ordered. For example, pod -2 is created after pod -1. So in the stateful set, we have this sequence number, like number of replicas. You have -1 -1, -2, -3, -4. So it's not like there will be random number. So it follows the sequence number. So if you give k scale sts, and let's say you have replicas equal to 5, so it will tell whether it is scaled up or down. So in this case, it's at scaled to that particular number. So rollout status of stateful set. So you can give k rollout status sts followed by stateful set name and the namespace. So this monitors a stateful set's deployment or update status, showing the ordered creation of pods. So it will look something like this. So previous command, and after this you can run this. So it will give waiting for 1 pods to be ready, waiting for 2, 3, and stateful set rolling update complete, 3 pods at revision. So it will give a revision number for the replica set, and it will show something like this. Next, set image for stateful set. So k set image, stateful set name, sts / and the actual name, then container name, whatever was in the YAML, whatever name you have specified. Then you will say which image with the label or the tag and the namespace name. So this triggers a rolling update of the stateful set by changing the container image. So there are a few examples are here. So k set image and MySQL container, and so we are setting to a new image. So we get a message saying that image updated. There can be multi-container stateful sets also. So one container and name followed by the image, second container name and the image. So it will just say which one is updated. So in this case, Kafka cluster is. So we are just updating this one. So image updated. If we have updated this also, it will tell okay, this is also updated. And if you want to do a record, you can say -- record, and this will when you do a rollout history, you can see the what command was issued for basically recording your event history. Next, rollback stateful set. So k rollout undo sts followed by stateful set name and the namespace name. So it will just roll back to the last previous version. So this rolls back a stateful set to its previous revision. And the command will give message saying that it is rolled back. So you can also, so if you don't specify the revision number, it will just say roll back to previous version. So like this, but you can roll back or undo to a specific revision number. And again, the message will be same, roll back. So get pods by label. So k get pods -l, label key, label value, and namespace name. So this finds all pods managed by stateful set using its label selector. And you can find the selectors via, you can use the k describe sts command first. And once you find those selectors, you can run this command to see which pods are controlled or maintained by the stateful set. So the output may look something like this. So in this case, you can see my cluster 0, 1, 2. So it has this numbering system sequence number for stateful set. This is unlike deployments. So exec into a stateful set pod. So command will be k exec -it stateful set name, namespace name, and sh command. So we are we are going inside a pod actually. So here get an interactive shell inside a specific predictably named pod. For example, the first pod will be -0. So this is one example. So we are saying MySQL cluster k exec it. So it is interactive and tty -n production and -- sh. So after that you will get the shell into that particular pod of the stateful set, and you can run regular command like ls, ps, and so MySQL is available because this is a MySQL stateful set pod. Next, explain stateful set. So k explain sts. So this shows the API documentation for the stateful set resource. And this is how the whole stateful set API documentation will be shown, and it will show the first level field like API version kind, metadata, spec, status. So you have to basically drill down if you are interested in, for example, if you want to know what is under spec, so you have to give further. So I'll show you in the next command. So let's say I want to know about volume claim templates because that's more integrated or most used. Like it's used more often with stateful set. So k explain sts.spec.volume claim templates. So this will this drills down to show the documentation for the volume claim template section, which is unique to stateful sets. And once you issue the command, it will go to the specific element in YAML in the hierarchy, and then it will talk more about volume claim templates. It will give a description followed by what fields are part of that, like volume claim templates. So it will show more information about volume claim templates. And to delete stateful set, so there is just you can delete sts name. This is optional field. This is by default, it's not used, and the namespace name. So when you don't use it, I'll just tell what is the difference. So this is an explicit way to delete a stateful set while guaranteeing its pods are left running orphaned. The default is dash cascade background. So we don't use this option. So it will delete the pod also, which deletes the pod also. But if you want to keep the pod, you will just say cascade orphan. So some examples are, so we are saying, okay, this will delete. So this is same as cascade background. So if I say cascade orphan, it will keep the pods. And one more option, cascade foreground. So this will also be same as background, but it will wait like synchronously, and it will let you know once you see this command like message back, then you know, okay, it's all deleted, all the pods. Okay, and that's all. Thanks for watching.